Right now, in this very room, a black hole the size of an atom might be passing through your body. Not through a screen, not in your imagination. For real, physically, through flesh, through bone, through air. It would leave no burn, make no sound, pass clean through in a fraction of a second, and keep going, into the dark, toward the next star. We call them primordial black holes, objects that weren't born from a dying star, but from the raw fabric of space itself. In the first second, the universe existed. No one has ever seen one directly. But in November 2025, one of the most sensitive instruments on Earth may have caught one in the act. This is a story about ghosts left over from the birth of time, and why everything we call dark matter might just be billions of invisible holes flying through us right now. Understand how strange primordial black holes really are. We first need to remember how ordinary ones are born. A normal black hole is a tombstone. To create one, you need a dying star, dozens of times more massive than our sun, that has burned through its fuel and collapsed in on itself under its own gravity. It's a slow process spanning billions of years. The star is born, it lives, it ages, and only at the very end does it collapse. Primordial black holes break that rule completely. They don't need a star. They don't need billions of years. They need only one thing: a tiny region of space where the density of matter in the first fraction of a second after the Big Bang was just slightly higher than everywhere else around it. In that scorching soup of the universe's first moments, space wasn't smooth yet. It boiled. It pulsed. It trembled with random clumps and gaps of matter. And wherever chance dropped in just a little more density than needed, gravity didn't wait billions of years. It collapsed matter into a black hole instantly, in a fraction of a second after the birth of time itself. These holes could have formed at almost any size, from the mass of an asteroid to a mass billions of times greater than our sun. The idea was first proposed in the depths of the Cold War by Soviet physicists Yakov Zeldovich and Igor Novikov. In the early 1970s, Stephen Hawking took the idea further, suggesting there could be a huge number of these objects, that they might radiate energy, and that they could turn out to be the answer to one of physics' greatest mysteries: what dark matter is actually made of. The problem is, for half a century, no one has ever found one. Not a single direct photograph, not one undisputed trace. Primordial black holes remained pure mathematics, a beautiful hypothesis without a single piece of proof. Until recently. In November 2025, the LIGO Observatory, one of the most sensitive instruments ever built by human hands, caught a signal that didn't fit any known pattern. LIGO detects gravitational waves, ripples in the very fabric of space-time, born when ultra-dense objects collide. Usually those are collisions between ordinary black holes, the remnants of exploded stars. Their masses range from a few solar masses to billions. But in November, LIGO's automated system flagged a merger in which one of the objects weighed less than a single solar mass. That's impossible to explain through ordinary stellar evolution. A star that's small can never collapse into a black hole. The laws of physics simply don't allow it. So either this is an instrument error, or we're looking at the first direct evidence of a primordial black hole in the entire history of science. Physicists Niccolo Capelludi and Alberto Magaraglia from the University of Miami ran the numbers. They tried to estimate how many primordial black holes should exist in the universe and how many such mergers LIGO should statistically be catching. The result matched. The rarity of these signals lined up perfectly with what you'd expect from primordial black holes, not statistical noise. Capilouti stated flatly that this is the most plausible explanation for the LIGO signal, one with no conventional astrophysical interpretation. According to him, these objects could account for a significant fraction, maybe all, of dark matter. But not everyone agrees. Some astrophysicists argue the signal is just noise inside LIGO's extremely sensitive detectors, a statistical fluctuation that's too tempting to mistake for a revelation. Confirming it would take another merger just like it, maybe several. For now, it's a ghost on the edge of detection. Either the first echo from the dawn of time, or just the tremor of an ultra-precise machine. But LIGO wasn't the only place people went looking for proof in 2026. Some decided to look not at gravitational waves, but straight up into the sky. And what they found turned out to be far closer to home than anyone expected. In May 2026, a team led by Renee Kai at Swinburne University of Technology in Australia published 2 preprints with a claim many physicists called too bold to be true. They said they had spotted something passing through the halo of our own galaxy, the sparse outer edge of the Milky Way, believed to hold most of its dark matter. The object was unofficially named Phoebe. By their calculations, its mass was roughly 3 times that of the Moon, a tiny black hole that flickered into view for a moment, then vanished just as suddenly as it appeared. Kai herself admits the observation is disputed, brief, and will be extremely hard to replicate or confirm independently. But even a disputed sighting shows just how desperately physics is searching for an answer to the mystery of dark matter. And that raises an uncomfortable question. If objects like this really do make up dark matter, why can we ever catch them at all, instead of only catching their deaths? Because primordial black holes die. In the 1970s, Hawking proved that they slowly evaporate, and the smaller the hole, the faster it goes. Most of the tiny ones vanished long ago. Some literally exploded within the first fractions of a second the universe existed. In 2026, researchers from the Free University of Brussels and MIT proposed that these explosions might have solved one of physics' oldest puzzles: why matter ever won out over antimatter at the birth of the universe. You might exist only because, somewhere in that first fraction of a second, a black hole smaller than an atom exploded. But not all of them died. The larger ones, asteroid-sized, moon-sized, could easily have survived all 13.8 billion years of the universe's history, and could still be drifting silently through the galaxy today. We don't know if Phoebe was real. We don't know if the LIGO signal was her echo. Neither claim is proven. Neither is disproven. And as long as that's true, somewhere out there in the dark between the stars, ghosts from the very beginning of time may still be moving, passing through everything in their path, including perhaps you. If stories without answers keep you up the way they keep us up, subscribe to Star Voyager. The universe's next mystery is already waiting.